Hello everyone, welcome to Zaref Game Dev. In this video, we are going to create the Traffic Arrow game in Unity. So it's a simple hyper casual game, and the project files are available in my GitHub repo. And the full video is also available on my Udemy course, for which the link will be given below. If you want to buy it and support me, you can buy it. And thank you everyone else who has bought it. And all the courses are going to be completely free on YouTube, so they are going to be same videos. Just instead of part by part, it will be maybe one whole long video. And it's a pretty similar game where we just avoid the obstacles, and the obstacles have just a random movement. And as you can see, it is pretty similar. So if you do like the game, then subscribe to the channel, and you can follow along any of my social media sites, and let's start creating. So let's start by setting up our project first. So we have an empty Unity project opened up. It just has the sample scene, and first of all we'll change our build settings, and we'll change it to Android. So let's switch the platform to Android. It will take around 20 to 30 seconds. And after switching our platform to Android, let's create a new scene, and we'll call this main menu, and we'll save it inside our scenes folder, and we'll delete our sample scene. So there we have our main menu. Let's delete our sample scene, and we'll also remove it from our build, so we can it doesn't get any error. And we'll add our main menu scene to the build so we can access that scene. And again, we'll create one more scene, and this is going to be our gameplay scene. And we'll save our gameplay scene and add it to the our build. And after that, we'll get inside our project settings, and we'll set the time scale to 0.01, and we'll import TextMesh Pro. So after importing TextMesh Pro, we need to disable the warnings, and let's set the editor prefab to use underscore naming. And inside our script execution order, we also need to change it. And let's see if toolchain management is turned off. So okay, it is turned off. And now we'll set up our packages. So only four of the packages we are going to need, which is going to be our TextMesh Pro, Timeline UI, and our Visual Studio Editor. We'll uninstall the rest of the packages. So it uninstalled the JetBrains Rider editor, and now we'll install our test framework. And we'll uninstall version control, and we'll also uninstall the visual scripting. So again, it may take 10 to 15 seconds. So let's uninstall visual scripting, and it will take a couple of seconds. And finally, what we are going to need is our VS Code editor. If you are using VS Code, then you can uninstall the Visual Studio editor, but most likely you will be using Visual Studio. So let's remove the VS Code editor, and we'll update our Visual Studio editor to the latest version. So that was for our packages, and now what we need to do is import all of our assets, and we'll need to change the script execution order as in the previous games. So let's bring inside our editor folder. It should be inside our assets, and it's going to include all the colors that we are going to need. And after that, we are going to bring in our resources folder, which includes all the fonts and the fonts, images, and the sound that we are going to need. And let's create one more folder to store all of our prefabs, and finally we'll create our scripts folder. So it's a pretty small project, so anything else you need, it should be included in any of these folders. So let's create our scripts. So the first script we are going to need is our game manager. Then we are also going to need our gameplay manager, and after that we'll need our main menu manager, and finally our sound manager. And for our gameplay scene, we are going to need the obstacle and the player script. So we'll also create them here. So player and finally our obstacle. And let's assign the script execution order, as we need to have our game manager at the start, and it doesn't matter what the rest of the execution is, but we need the game manager at the start, and also our gameplay manager is going to access it. So our game manager should execute first, and that was for our project setup. And the next part will start editing our main menu scene. Again, it's going to be pretty similar to what we have done. So let's go to the next part. So we have set up our project, and we are going to create the default look for our main menu. So let's first go to the main camera and change its background color to the black one. And after that, we are going to add a text which is going to be title under slash one, and it is just going to call traffic. And let's change its size to 10 to 4 by 5 and 2, and let's move it to the center, align to the center. And for the color, we are going to use the green one, and let's increase its size to 128. And for the font, we are going to use our type source font. So as you can see, it is looking perfectly good, and we'll need to set up our canvas. So we need to have it to the render on the camera, and we'll need to have scale it with screen size, so 1080 by 2160, and we'll have it match the height so it aligns perfectly. And it is going to be positioned from the top at negative 256, and let's increase its size to 160 so it looks good. And after that, we'll duplicate our title one, and it is automatically renamed to title 2 negative 256 plus 64. And this one we are going to call arrows, and we need to change our O to be different, and we could have arrow. Yeah, let's just have it as arrow. And after that, we'll need to create an image which is going to be for our play button, and it is going to be at 256. The width and the height is going to be 256 by 256. The sprite is going to be the circle, and the color is just going to be set the transparency to 10. So it looks a little bit lighter. And we'll also need to attach a button component, and we'll need a play button inside it. So let's add one more image, and doesn't matter what we call it, let's assign the play button, and it is going to be 256 by 160. Let's position it a little bit to the right, and for the color we are going to use the default white. So we should have a white, yeah, it's white. And after that we'll add one more text, which is going to be for our score, and it is going to be positioned from the bottom at 768. The size, let's use 10 to 4 by 5 and 2. Position it to the center. Size is going to be 128, and let's use our type source font, and the text is just going to be some random number. And let's duplicate the score, and this one is going to be for our high score, and we'll position it at 256. And let's duplicate our score again, and this one is going to be for our new best, and it is going to call new best. We'll position it 128 below, and one more 16, and its color is going to be our green color. Not green. So the size will need to change it to 96, and instead of green we are going to use light color, and the position is going to be 608, and let's duplicate this new best, and this one we are going to just call best, and as you can see it is going to be positioned at 128. So both are just showing us the scores, and the new best, it is going to be 768 minus 128. So after we have our main menu look correctly set up, we are going to create our main menu manager, which is going to have the main menu manager script attached, and also our game manager, which is going to have our game manager script attached, and finally our sound manager, which is going to have the sound manager script plus an audio source. And let's hit play, and let's hit apply. There should be something remaining, and mm, yeah, so everything's working perfectly fine. There are not any issues, and we don't need the project settings. We just need our scene and our simulator. So let's see how it looks in other ratios. So we'll need a portrait. So everything's looking perfectly fine, and that was our main menu setup. In the next part, we'll code up our sound manager and the game manager. If you want, you can directly just copy paste the whole script. Everything is similar, variable names are similar. All you need to do is reassign the references. So let's start coding our sound manager and the game manager. So we have our sound manager script opened up. Let's delete everything. And first thing we are going to need is a static reference to access our sound manager, and we'll call this instance. And when awake, we are going to set up our instance. And if our instance is equals to null, Then we'll set our instance to this, and we don't need to destroy and load our game object, and then we'll return. Else we'll just destroy our game object. And it's just going to have one function, so audio source, and we'll call this effect source. And what we'll have is a public method to play the sound on this source, and we need to pass an audio clip, and we'll just call it clip, and we'll use effect source dot play one shot, and we'll pass our clip. So that was just for our sound manager. Now let's set up our game manager. So again, our game manager is going to have a static reference, and inside our awake we'll check if our instance is equals to null. Then we'll set our instance to this, we'll set it to not destroy on load, and return. Else we'll destroy our game object. And we also need to initialize our game manager, and we need to create an init function, and what it is going to initialize is a public bool is initialized, and we are going to have a getter and a setter, and a public int for our current score. And again we are going to have a getter and a setter, and also a private constant string for our high score key, which is just going to be high score, and we are going to have a public integer to get and set our high score. So in the get, we'll just get our high score key with a default value of 0, and inside our set okay, so get we need to use return, and inside our set we'll just set int, and we'll pass the high score key, and we'll pass our value. And inside our init function we'll set our is initialized to false, and our current score will be set to 0. And similarly we are going to have two functions, so private constant string, and the first one is for our main menu, which is just going to be our main menu, and the next one is going to be for our gameplay. So we are storing it as variable, so whenever we want to type it, just auto, what do you call it as, yeah, it just shows up. And we'll create two methods, and the first one is going to be go to main menu, and inside our go to main menu use unity engine dot scene management dot scene manager dot load scene, and we'll pass the main menu, and inside our go to gameplay we'll pass our gameplay string. So that was it for our sound manager and the game manager. Now let's go inside Unity, and let's set up our sound manager's reference, which is just the audio source, and game manager doesn't need any reference, and let's hit play. So nothing's showing any errors, so the script is working perfectly fine. And next we need to do is set up our main menu manager. So we'll do it in the next part. So we have our game setup. Now let's open our main menu manager, and we'll go inside Visual Studio, and it's just a little bit of code as we already done before. So let's see, where should we start first? Okay, so only the gameplay manager is going to be a little bit large. Not large, just simple, but we'll see what we need to do. So inside our main menu manager, we are going to have a serialized field for the private TMP text. And the first one is going to be for our score text. And the next one is going to be for our high score text, and finally our new best text. And inside our awake method will check if GameManager.instance.is initialized, then we'll start the coroutine, which is our show score. Else what we'll do is we need to set our high score text to be GameManager.instance.highscore.toString. And before that, we need to hide both of our score and our new best. So it was already shown, and we'll hide it. And after that, we'll need to create a public method when our button is played. So we'll call it click play, and it is going to play the sound first. And here we need to create a variable to pass our audio clip, which is going to be our click clip. And we'll pass our click clip here. And after that, we are going to go to our gameplay scene. Go to gameplay GTG, and we need to create our enumerator. So private enumerator, and we'll call it show score. And let's use a yield return null, so everything's fine. And we don't need the generic, and to show our score we are going to have a float for our animation time, and a serialized field private animation curve for our speed curve. And let's see what we need to do inside our score. So let's get a reference to our temporary score, and we'll set it to 0, and we'll set the score text to be our temporary score dot to string, and we'll get our current score, which is going to be from our game manager, and also our high score, which is again going to be from our game manager. And if our current score is greater than high score, that means we created a new high score, then new best text dot game object dot set active to true, and our high score needs to be changed. So game manager dot instance dot high score is going to be equal to our current score, else we are going to hide our new best text. And after that, we'll set our high score text, and we'll need to get it from our game manager, and we need to convert it to string so it doesn't mess up. And after that we'll start animating our score. So 1 divided by animation time, and float time elapsed is going to start from 0. And after that, while our time elapsed is less than 1f, our time elapsed going to be increased by speed multiplied by time dot delta time, and our temporary score is going to be an integer, and we are going to multiply it by the current score, and we'll pass our speed curve dot evaluate, and here we'll pass our time elapsed, and we'll set our score text to be our temp scores to string, and finally we'll wait for 1 frame, and at the end we'll set our temporary score to be equal to current score, so it shows whatever score we have, and set up our score text. So everything's pretty simple, and we already have done it before, so it was pretty fast. Now let's go inside Unity and let's set up our main menu manager. So let's add the speed curve to be fast and then slow. Audio clip is going to be our clip animation time. Let's set it to 1.6, maybe 2 point, let's just set it at 1.6. Our new best text and our high score text and also our score text. And now suppose if we didn't had any problems, we should be able to see the score, which is already shown, and I already played it before, so it has that stored in the player prefs. And we'll assign our button function, so it is going to be main menu manager, and click the play, and let's hit play, and when we hit play button we should be able to hear the sound and go to our gameplay scene. So that was for our main menu, and the next part will set up our gameplay scene and all the scripts. So let's go inside our gameplay scene and let's set our gameplay scene first. So let's set the main camera's background color so we can see it clearly, and we'll change its size to 21.6, and there is just going to be one score, which is going to be the text, and we'll set its size to 10 to 4 by 5 and 2, and the text is going to be some number, and it is going to be positioned from the bottom at 128. Let's have it aligned to the center, and we'll set its color to be the blue color, and let's increase the font size to 128, and finally we'll set its font to our type source. So as you can see, we can see the score below, and let's set up our canvas. So have its screen space camera, constant pixel size to scale its screen size, 1080 by 2160, and we'll have it match the height. So that was our UI, and after that we'll need to create 4 boundaries on which we'll need to attach colliders. So whenever a player or obstacle hits there, we'll need to deflect them. So if it is at the side, then its x velocity is going to be inverted. It will be multiplied by -1. So let's create our first border, which is going to be our left, and we'll need to have 2 tags. So the first tag is going to be the side, and the second tag is going to be the top. And for our side, let's add a box collider 2D, and we'll tag it as side, and we'll convert it to trigger, and the size is going to be 3.2 by 43.2. So as you can see, it is taking up our whole screen. And we'll position in the X by negative 12.4. We'll duplicate our left, and we'll just rename this to right, and it will be at positive 12.4. And again we'll duplicate our right, rename it to top, and it is going to be at 0 and 23.2, and we'll change our size to 21.6 and 3.2. So as you can see, it is at the top. And again we'll duplicate our top, which is going to be our bottom, and it is going to be positioned at negative 23.2. So these are our four borders, and when any of our obstacle or player hits them, it is going to get bounced. Now let's create our player, and it's going to be positioned at the center for now, and our player is going to have a sprite renderer, which image is going to be circle instead of simple. Let's make it sliced, and the color, it is going to be 169, a bluish one. And ordinary layer, let's set it to 0. It's going to have a circle collider 2D, and we are going to detect collisions on it, so we'll also need a rigid body 2D, and we don't want it to be affected by gravity, and also a player script. And it is looking pretty bland, so what we'll do is we'll create an empty, and we'll call this arrow, and this arrow is going to be pointed. Let's add a sprite renderer, and we'll assign this arrow, and it needs to be a little bit on the top, and instead of simple we'll make it sliced, have it a little bit larger, and the color is going to be our 821667. Why is it so its color is going to be our white color. And finally we are going to have our gameplay manager, and we need to create a template for our obstacle, so let's call it obstacle, and let's reset its transform, and it's going to have a tag of obstacle which we'll need to create. So let's assign a tag to obstacle. Let's add a sprite renderer, and it is going to have the sprite of the circle, make it slice to cross to order in layer, let's set it to 0, and its color, it's going to be white, and it is going to have a circle collider 2D, which is going to be a trigger, and also rigid body 2D, cause it's going to be needing some bouncing across the walls. And after that it is going to have an obstacle script, and again we'll create an empty, and we'll call this cross, and our cross is going to have a sprite renderer, which is going to be our cross at the top, instead of simple make it sliced, add 1.6, and the color is going to be our dark color. So this is our obstacle, and we are going to save it as our prefab. So maybe, yeah, this is going to be the only prefab that's going to be there, and that was it for our gameplay setup. Rest we are going to do is add our script to the gameplay manager, and let's add the scripts first. So let's open our gameplay manager. So we'll just create the default variables which are going to be from the awake methods, and let's create a region for the start and end region, and public bool as game finished, and our public static gameplay manager instance. And inside our awake, we'll just set our instance to this, and as game finish to false, and game manager dot instance, and is initialized is going to be true. And after that, we are going to spawn some obstacles, but before that, let's see what's going to happen when the game is over. So hashtag region, and we'll call it game over. And inside our game over region, we are going to have a public unity action, and this is going to be our game end, and our public void game ended, which is just going to call our game over enumerator. So inside our game over enumerator, we'll wait for 2 seconds, and then we'll game manager dot instance dot go to main menu, and we'll start our coroutine game over, and when the game ends, we are going to play our loose clip, which will need to it created, but where is it? Yeah, it didn't create, so we'll need to create our loose clip, which is going to be private audio clip, and yeah, that should be it. And we need to invoke our game end, set up our current score has game finished is going to be true, and our game manager dot instance dot our current score is going to be equal to cast it to an integer of score, and we'll need to create the score, and it will be inside another region, so we'll see what we need to do. So let's create a hashtag region for our score, hashtag and region, and let's create a private float of score. That should be good. So there are not any errors, and our score is calculated. So that was just the basic setup of our gameplay manager. When the game ends, we just set up the score, and when the game starts, we are going to set the score and spawning. We'll set up the spawning in the next part, and all that will be remaining. Yeah, we'll set up the gameplay manager script in the next part. So we have our gameplay manager set up, and We need to hide an inspector our has game finished so it doesn't show up. And let's assign our loose clip. And what we need to do is spawn our obstacles, but first we'll code up our obstacle first. So what it's just going to have is some random motion, and when it collides with any of the directions, it is going to just change its direction. So let's go inside Visual Studio. Inside our scripts, we'll code up our obstacle first, and then we'll start adding the obstacle spawning logic. So let's create a serialized field, and we'll call it private float, and it is going to be our move speed and our private vector 2 of move direction. And inside our await, we'll set our move direction to be new vector 2, and here we'll use dot normalized, and what will pass in the x and the y coordinate is a random dot range from 0 till 1, and again random dot range from 0 to 1. Instead of 0 to 1, we'll need to have the -1 also. So this is going to be a move direction, and there is not going to be anything else. And inside our fixed update, what we'll do is we'll set the transform dot position to be equal to our casted to a vector 3, and we'll pass our move speed multiplied by the time dot fixed delta time, and finally multiplied by the move direction. And we need to add on trigger enter. So on trigger enter 2D, if our collision dot compare tag, if we are colliding with a side, then we'll change the move directions x to be multiplied by -1f. And similarly, if we are colliding with vertical sides, then we'll multiply the y direction by -1f. And that should be it. And now we need to spawn our obstacles inside our gameplay manager. So let's go to our gameplay manager, and let's see what should we assign first. And first our score is going to be 0, and our current level is going to be 0, and our yeah, so our ending condition is done. So let's create a private float score, and we'll create a private int for our current level. Private float for our score speed, and serialized field private list of integers for our level speed, and also our level max. Serialized field private tmp text, and this is going to be for our score text, and serialize field private game object, and this is going to be our obstacle prefab, and serialize field private float for our spawn x and spawn y. And let's first calculate our score as we already done it before. So if our game has finished, then we'll return, else we'll start calculating. So the score plus is going to equal to score speed multiplied by the time dot delta time, and our score text dot text is going to be casted to an integer for our score and dot to string. And if our score is greater than our level max, and we need to pass our mathf.clamp our current level between 0 to level max.count. Then we are going to increase our current level. So the current level is going to be mathf.clamp current level plus 1 and level max.count, and we'll spawn an obstacle, and our score speed is going to be equal to our level speed, and we'll pass our current level. And let's create our spawn obstacle. So inside our spawn obstacle, what we'll do is let's first get a spawn position, and unity engine dot random dot range from spawn x to spawn x, negative spawn x to positive spawn x, and again we'll use negative to positive, and spawn y to positive spawn y. And after we get our spawn position, we'll do a array cast hit 2d, and we'll just hit, and we'll use physics 2d dot circle cast, and we'll pass our spawn position, and the radius is going to be 1, and the direction is going to be 0, and bool can spawn is going to be hit, and if we can spawn while we can spawn, we'll do the previous steps again. So when we hit something, we need to change our position, and when we don't hit anything, it is going to return null, and our can spawn is going to be false. And what we'll do is we'll instantiate our obstacle prefab at our spawn position at quaternion dot Euler of 0 0 unity engine dot random dot range, so it is going to have some rotation from 0 till 37, and we multiply it by 10f. So this should spawn an obstacle. And inside our awake method, we need to set our score speed to be equal to level speed of our current level, and our score text is going to be equal to score dot toString. Cast it to an integer, and it needs to have a bracket, and after that we'll spawn 8 obstacles. So we'll spawn an obstacle, and that should wait for the start function. The score is going to calculate the score, and the obstacle is going to calculate the obstacle. So yeah, and that should wait. And let's go inside Unity and let's see if it is working. So there's an error for a bracket, nothing else. And now it should be fixed. And let's put in our variables. So for our spawn x, we are going to have 9.2. Spawn y, we are going to have 20. For our prefabs, we are going to pass the obstacle. The score text is going to be the score. The level speed is going to be 5, 10, 20, 50, 100, 500. 5, 10, 20, 50, 100, and then 500. And similarly, our level max is going to have 25, 75, then 200, 500, 1000, 200, 500, 1000, and finally let's use 1 million so it doesn't go out of bounds. And inside our obstacle, all we need is our move speed, which is going to be around 8. And let's see if our game works perfectly fine. So let's go inside our scenes and let's go to the main menu and let's hit play. So as you can see, there are obstacles uh, just moving around, and this is our player. And after we have our player moving and have detect collisions, we should be able to finish the game. So let's go to the next part. So we have our gameplay scene perfectly set up, and the only thing that's remaining to do is have our player moving depending on where we are clicking, and bounce around the edges, which we have done with the obstacle. And also the movement direction is going to be the direction vector from where we are clicking. So let's go inside our gameplay scene, and let's code up our player. So it is again going to be pretty simple, and let's delete everything. Yeah. So I didn't think we needed the game and function, but why was the game and needed? Our obstacle. Yeah, we are not going to have any animations, but if we are going to have any animations and we want to show our obstacle exploding, we'll have the game and animation. And let's start editing our player. So our player is going to have a serialized field private float for our mouse speed, and private vector 2 for our move direction. And inside our awake, we'll set our move direction to be up, and inside our update, whenever we click, so if input dot get mouse button down of 0, then we need to change our direction. So let's first get our mouse position. So it is going to be camera dot main dot screen to world point, and we'll pass our input dot mouse position, we'll convert it to 2D, and it is going to be new vector 2 impose dot x and impose dot y, and our move direction is going to be equal to mouse pose 2D minus our vector 2 transform dot position, and we'll have it normalized. And before that we need to convert it to vector 2 and then have it normalized, and we need to set our rotation to be quaternion dot Euler of 0 0 and cos angle. So let's calculate the cos angle, and it is going to be mathf dot inverse cos, and here we have our move direction dot x, and it is going to give us a value in radians. So again we need to convert it to degree, radian to degree. And it is going to be equal to cos angle and multiplied by our move direction dot y. If it is greater than 0, then we'll multiply it by 1f as negative 1f. So it will set us our rotation. And inside our fixed update, we are just going to set our position, and we'll convert to a vector 3. And what we are going to pass in our vector 3 is our move speed multiplied by time dot fixed delta time and multiplied by our move direction. And similarly, we'll copy our on trigger enter for our layer, so side and top, but it is also going to have one more. So if our collision dot compare tag of our obstacle, then we are going to gameplay manager dot instance dot game ended, and we'll destroy our game object, and then we'll return, and that should be it for the playoff. So let's go inside Unity and let's set up our player's direction and speed. So we'll just have it, and there were not many changes. So let's go inside the main menu and let's see if our player is working perfectly fine. So the direction seems to be something else. Cause we added, so the game ended and the sound was played, we scored a new best, and there's something going on. Move direction dot x and cos angle multiplied by 1 or negative 1. So why did it happen? Mouse pose 2D minus vector 2 of transform dot position. So our game's perfectly fine. There's just some issue with our directions. So game manager, yeah, I got it. It's because our arrow is pointing upwards. We need to set its rotation to 90 and negative 90. So for the 0, it should be to the right, and that was just the issue, the relative angle. So it was moving to the left, now it is moving to the right, and the game finished, and that was it for this game. And if you guys watched till now, thank you guys for watching, and see you guys in the next video.